so again, we're back in the blue packet. We have 2 pages yet on that one that I'd like to finish off today. It starts with exploration on the top is the one. It's the one right after the population problem type 1. Okay? All right? And then we'll talk about the other sheet that you picked up on the way in today. Okay? So we're back in the blue. Again, you need a calculator for today. If it's a graphing calculator, that's fine. If it's a non-graphing calculator, that's fine also. Okay? I have to go here and bring this up just a little bit so that I can have that underneath there. So I have my calculator and I'm ready to go. Awesome. That's awesome. Okay? All right. So, by the way, I think we should all just take a moment here and say hi to Maddox, who's joining us on the interwebs. So everybody say hi, Maddox.
Hi, Maddox.
There's your shout out. Okay? All right. She just texted me and wanted a shout out on the video because she's watching it. Okay? All right. So this will require some previous knowledge that you had using of inverses and how do we solve these following equations and tap the brakes. Wait, am I on the wrong? Oh, see, wrong one. Ay, caramba. Went to the wrong spot. This one needed to go there, and then I needed to go there, and then I needed to go there. Now we're set. Okay. All right. So, suppose that we have f of x equals 3 times 2 to the x. We were talking about this one earlier this week, and at the end of last week, we were talking about these type of exponential functions and how, yeah, they're great and all, but at the same time, they're like exponential functions with training wheels. Okay? All right? What we're going to do today is we are going to change that over into higher level math, the e function. So we want to get that function to look like this. The exact same function. If we graphed them, they would be one right on top of the other. If we plugged in any point, we would get the same values out on all of them. Okay? Well, if I want them to be equal, what do I need to do? If I want them to be equal, what can I say about them? I can set them equal to each other, because if I want them to be equivalent, if I want them to be the same thing, then I'm going to put them as the same thing. So the very first thing that I would do then is I would set them equal to one another. E times 2 to the x power, 3 times 2 to the x power equals 3 times e to the k power to the x power. And now I've got to solve that for k. All right? So what would you do first? Divide both sides by 3, because your a value is going to be the same for both of those functions, because they need to go through the same y-intercepts. So your a value has to be the same. Okay, so we divide both sides by 3, or we divide both sides by a. Okay, and that leaves us with 2 to the x power equals e to the k power to the x power. Okay? Now, since I have equal exponents right here, I've got equal exponents there. That means that because this is an equality, the bases have to be equal. So I could think about it as in terms of I take the x root of both sides. Okay? If I take the x root of both sides, then I get 2 equals e to the k power. And now I'm stuck, because now I don't know how I'm going to find out what k is. Okay? So you've done some work with this kind of a thing before, and you know that we're going on a path that's going to lead us through the woods and to logs, okay? And natural logs and all that fun stuff, okay? So let's go down that road, okay? So let's take a step back and let's say x squared equals 9. How would you solve x squared equals 9? You'd what? You'd square root both sides, right? Because that's the inverse of squared is square root. Okay? What do you get for an answer there? Plus or minus 3. Okay? Not just 3, you get plus or minus 3 here. X squared equals 10. What would you get there? What do we get for x here? What you got? Plus or minus the square root of 10. Love it. What about the next one? Roll. What would we do? How would we go about trying to find what theta is here?
Inverse sine 1/2.
Inverse sine. Yep, we would take the inverse sine of 1/2. Or on this other one, we would take the inverse sine of 2/3. Now, one of those is on the unit circle, okay, which is the 1/2 one. So if I go over here, you know, I love this part about this room is last year somebody made us a window sticker of the unit circle. Okay? So sine is y's on the unit circle. You learned that last year in the algebra 2. Okay? So I look for where my y value is equal to 1/2. Well, that happens at pi over 6. And then that happens again at 5 pi over 6. So my two answers for this one are pi over 6 and 5 pi over 6. Oops, wrong color. On the other one, that one's not on the unit circle, so then I've got to go to a calculator, and I've got to say, well, the inverse sine of 2/3 is, oh man, it doesn't give me anything. So what if I went like that? Oh, okay, that's not bad, but what's wrong with that? Or what do we know about that? Which is probably different than the one that you're getting on your calculator of 41.8. This one's in radians, and I know that because up here in my calculator, right there, it tells me that I'm in radians. Okay? All right? So that's my one. And then I would have to take pi minus that to get my other one. You would go, on that one, you would go 2 divided by 3 equals second sine 41.8. Okay? So on this one, we got, now I forgot what they were. Move this over a little bit. There they are. We got theta here equaling 0.729728 and 2.41186. Okay? And again, if we were doing this in degrees, then we'd have 41.8 degrees and whatever. So what's 180 minus 41 would be 39, 32, or 38, 138.2 degrees. What about these two? 3 to the x power equals 9. Oh, that one. What variable or what value of x would go in there to get me 9? We got one? 2. 3 squared is 9. So x has to be 2. Right? What has to go on, or what value of x has to go into the other one to get me 10? Don't know, do we? Don't know. All right. Well, let's come back to it then. All right. So if I recall from Algebra 2 that exponential expressions can be written in logarithmic form, then b to the x power equals y becomes x equals log base b, that's how we read that, log base b of y. Math is its own little language. Okay? And math's language has certain ways that we say things. Okay? So if we go back to that very first problem that we had, 2 equals e to the k power, and I want to solve for k, well, then if I switch that into logarithmic form, k would be equal to the log base e of 2. Do we ever write log base e? What do we write instead? Not in. Natural log. ln. Yep. So log base e is the natural log of 2. Okay? Which that I can type in my calculator now, and I can figure out what the natural log of 2 is. Natural log of 2 is 0.63917. 693,147. Okay. Now, I am going to store that in my calculator as my value of k. So now that that's stored in my calculator as my value of k. And I'm going to go back here now to this equation right here. Okay, whoops, dropped my marker. Okay, so then this is 0.693147 right there. Okay. If these two are truly equivalent, I can do two things. One, I can test some points, and I could say that f of 3 would be 3 times 2 cubed. 2 cubed is 8 times 3 is 24. So f of 3 should be 24. If these two functions are equivalent, then g of 3 should also be 24, and that would be 3 times e to the 0.693147 power times 3. And it should give me 24. Now, because I've got that stored in as k down there, I can go 3 times e to the 3k power, and when I hit enter, I better get 24. Bam. Got 24. Okay. Or I could prove this graphically. My first function would be 3 times 2 to the x power. There it is. Okay. My other function would be, or my next function would be 3 times e to the kx, oops, I got to put times in there, kx power, and there it is. Because I have it stored in as k, they go right over the top of one another. Okay. Now, if I go back here to this problem, 3 to the x equals 10. Now, if I want to solve that one, what's that one going to solve into? Or what's x going to be equal to in this particular one? What would x be equal to? Gil? Log of 10 over log of 3? That doesn't follow that you got 2 logs in a 1 log problem. Log base what? Log base 3 of 10. Okay? So that's what it would be equal to. Now, if I want, that would be the exact answer, right? I knew what you were doing. You were right. Don't worry. I just didn't want you to get, you were 4 steps ahead of us, and I only wanted you to be 1 step ahead of us. Okay? Now, if I want a decimal equivalent of that, now what am I going to do? I could do this on a calculator, right? If my calculator and some more calculators have this technology now, where we can find the log base 3 of 10, where we can find that, right? But not all calculators do. So we have something out there called the change of base formula. And the change of base formula would say that this would be log of 10 divided by log of 3, or the natural log of 10 divided by the natural log of 3. And in either one of those cases, it's going to be 2.0959. Which makes sense. I need to have an exponent of x bigger than 2, because 10 is bigger than 9, but smaller than 3, because 3 cubed is 27. 10 is in between 9 and 27. Okay. So, let's go back to our San Jose and our Columbus problems that we did earlier this week. In the San Jose problem, you should have gotten P of t equaling 782 times 1.01359 to the t power. 1.01359 to the t power. I would like to convert that one into a P of t equals a times e to the kt power problem. What is a? 782. That is going to stay the same. So automatically, my new function, P of t, is going to equal 782 times e to the kt power. Now I need to solve for k. How am I going to make those two be exactly the same? I could plug in points, okay, but then that would be tricky. What do you got? If I want them to be the same, I can set them equal to each other. Okay? So then I'm going to say that 782 times 1.01359 to the t power is going to equal 782 e to the kt power. What would we do next? Divide by 782. 0.01359 to the t power equals e to the kt power. Love it. What would we do next? What? Not square root t. T root, right? Take the t root of both sides. So 1.0359 equals e to the k power. And how would I solve for k? Nope.
Natural log 1.01359.
So k here is going to equal the natural log of 1.01359. Okay. Which is approximately the natural log of 1.01359 is that. Okay? Now, I'm going to store that as my new k. Okay, so 013,489. 013,489. 013. Was it 98? Man. Whoa, what's going on there? Okay. Now, if those two were equivalent, way back in that other problem that we did earlier this week, we said that in the year 2000, the population was 895,000. Right? Okay. But then we also said that this was year 10. because we made 1990 be 0. And we said that this was 895. So if I plug in, I'm just going to move Columbus here for a second. So if I plug in here, in my P of t, my function, 782 times e to the 0.013498 t power. So if I plug in 10 for t in that function, I should get out 895, correct? Okay, let's do that. If I plug in 10 into 782 e to the, I have it as k, 10k power, I get 895.014. Why is it not exactly 895? Anybody know why it's not exactly 895?
Rounding.
Where do we round? Where is it not exact? The 1.01359. That was rounded. Okay? Which then made that rounded at the end. But it was close enough where we could realistically say, yep, we found it. Okay? So this is the function here for San Jose. With that being said, what I'd like you to do now is I would like you to find me the Columbus function. I got my Columbus function, P of t is 633 times 1.01169 to the t power. Or it should be something close to that, right? Hopefully that's what Maddox got too. Second shout out. Got 1 0. Yes? Okay. Now, using the Columbus data, Columbus would have gone through, and this would just be, a quick simple check. The Columbus data in 2000, it would have been at 711,000 people. Okay. So again, that was the point 10, 711 in our data. So if I put that in. Now I'm going to store this as K again. And then now I'm going to go 633 e to the 10K power 711. Again, just happened to be 0.014. That rounding must be at, what we got? You would have to do your exponent first because you can't see what you type in. Times 10. Equals. I got to hit equals. You got to hit equals more often. Okay? All right, so the 3.3 cream-colored worksheet that you got today, when you walked in today, okay? So this cream-colored worksheet, there is videos to watch over the weekend, and I'll post this online for those of us not in class today. That 3.3 note sheet needs to be due or done, I should say, by your 4-mod class. There's videos to go along with it. Depending upon how much you remember is going to depend on how much videos you need to watch. But we will be walking around the room on Tuesday at the beginning of class asking to see this worksheet. Complete it as an assignment. Okay? Alright?
Are we able to do all of the homework then?
You should now be able to do all of the homework, yes, in the blue packet. Okay? Okay? 2. Yep, those 2. Okay? Alright? Handle? Love it? Awesome. If you don't have a printer at home and you're listening to me on the line, Mad Dog, I'm talking about you, you can stop by the pre-calc room on Monday and pick up a sheet so that you can finish it Monday night. Have a great day.